So now next method, like resistance, inductance, capacitance. Commonly if you want to know inductor and capacitor in a circuit, then you can use Maxwell's Wein bridge method. Okay, so this method is called as Maxwell's Wein bridge. So for this Maxwell's Wein bridge, the way the circuit will be is combination of inductance and capacitance. So this is also called as Maxwell's inductance and capacitance bridge. Okay, so let me just draw the circuit. As I said, circuit means always you have 4 legs. Okay, so always you have is 4 legs with an input. Okay, so usually this is the bridge circuit with an detector. Now here the difference is, of course, we have the same resistance here. There is no change in that. We are going to have same resistance in 4 legs. So these opposite legs will have only resistance. Okay. This opposite will have series inductance and parallel capacitance. That is the only difference. Okay. 4 leg bridge circuit with series inductance on leg 1, parallel capacitor on the leg 4. Okay. So our resistors are R1, R2, R3, R4, and our values are inductor and capacitor. Clear? So this bridge can also be called as Maxwell's inductance and capacitance bridge. Okay. So here usually what we can do is we will take an unknown self-inductance and this will be compared with the standard variable capacitance. So the capacitance we use here is an variable capacitance with an variable resistance. Okay. So here this is an self-inductance, variable capacitance, variable resistance. Okay. At the same way we are going to have resistors R1, R2, R3 and R4. So these are non-inductive resistance where R2, R3, R4 are known and R1 is unknown. Clear? So here the capacitance is an standard variable capacitance. So let me take it as C4 so that you won't get confused. It's in the 4th leg. L1, it means it says it is in the 1st leg. Clear? Now again same concept. According to bridge, R1 by R2 is equals to R3 by R4. But here if you remember, resistance means we will have R. Inductance means we will have j omega L. Resistance in series with inductance means R plus j omega L. Resistance in parallel with capacitance means R by 1 plus j omega CR. Clear? So same concept we are using here. Okay. So for that R1, what is R1? R1 is in series with inductor. Series with inductor means R plus j omega L means R1 L1 divided by R2 is equals to what is R3? R3 is R3 only. So R3, but R4 is parallel with a capacitor. Parallel with a capacitor means R by 1 plus j omega CR. R means R4, C means C4. Okay. So now let me just send this to the numerator. Okay. Because it is in the denominator. Okay. So now what I can do? or yes, it's okay. So let me just send like that. So now what happens? Or let me just send numerator to denominator, that will be cross multiplication, that will be very fine. So let us do that. R1 plus j omega L1 into, this is gone this side. So R4 by 1 plus j omega C4 R4 is equals to R2 is gone this side. So R2 R3. So now this is our equation. So from this equation, what we can do? Let us just write R1 plus j omega L1 into R4 divided by 1 plus j omega C4 R4 is equals to R2 R3. Right? So this way what happens? Multiply these two. R1 R4 plus j omega L1 R4 is equals to, this one I am sending this side, R2 R3 into 1 plus j omega C4 R4. Multiply this also. This is R1 R4 plus j omega L1 R4, which is equals to R2 R3 into 1 is R2 R3 plus R2 R3 into this. So j omega C4 R4 R2 R3. Now usually what we do? We do is real equate. So when you are equating real, R1 R4 is equals to R2 R3. Usually our R1 is the unknown value. So R1 is equals to R2 R3 by R4. So if you want to know the value of unknown resistance, you can use this formula. Then at the same way, imaginary equation you should equate. So imaginary means this equation is equals to this. So j omega, let us eliminate there itself, not to waste time. L1 R4 is equals to C4 R4 R2 R3. R4 R4 cancel. Therefore L1 is equals to C4 R2 R3. Capacitor is a variable capacitor. So I found the formula for L1. Depending on your problem requirement, sometimes you can even use C4 is equals to L1 by R2 R3 depending upon the question asked. But usually these are the unknown resistor and unknown inductor values. So this is how Maxwell-Wein bridge work. Maxwell means inductor, Wein means capacitor, and both methods when they are equated, this is the method. Clear? So finally we got resistor and inductor formulas. That's it. This is Maxwell's Wein bridge method.